This. Yeah, there's no algebra there. Second rule. Change everything into sines and cosines. What's cotangent?
1 over sine over cosine.
Cosine A over sine A over sine A over cosine A. Remember I told you back a little bit? I said if tangent is sine x over cosine x, then cotangent is going to be flip, right? And I said it's handy to memorize that. Or at least memorize it's the flip of tangent, which you have to memorize anyways. Fraction divided by a fraction, how do I simplify that using algebra? Flip and multiply. So I've got cosine A over sine A times flip cosine A over sine A. Cosine squared A over sine squared A, and I'd accept that as a final answer. What do they want?
Cotangent.
They want cotangent square root of A, because it's cosine over sine squared.
But you'll accept.
I would accept the first thing. By the way, it's simplification problems. You're not going to have any simplification problem in your test. We're doing that first simplification step before you start doing the real things.
What?
Oh yeah. Oh yeah. And then I'm going to ask you number 3, which is totally miserable. Enjoy the experience. Number 3, try it out.
Squared x plus cos.
Is it that?
No.
Then I can't do it.
Well, wait, can you go back like a second?
No, I'm doing the next problem. So we start off with sine squared theta cosine squared theta minus cosine squared theta. You follow Mr. Rezzi's rules. Okay, do some good algebra. No algebra there to do. Rule number 2. Let me try rule number 2. Rule number 2. Rule number 2 is what? Changing the sine and cosine. That's sine, that's cosine, that's cosine. I'm pretty much done. But it says simplify, so I got to do something to it. So what am I going to do? I'm a little desperate. You know, we have an identity that's sine squared and cosine squared. You guys were talking about that earlier, weren't you? Wonder if we could use that in a different way. I wonder if we took sine squared theta plus cosine squared theta equals 1. And see, the sine squared is the problem, right? Because it's different than the cosine squareds. So I can change it to a cosine squared by doing what? Sine squared theta plus cosine squared theta equals 1, right?
Yeah.
So therefore, sine squared theta equals 1 minus cosine squared. That's new.
What are you trying to do?
I want to turn everything to cosine now. Okay? Because I got a sine squared, I can change sine squareds into cosine squareds. I can turn cosine squared to sine squared. This sine squared is the problem. I'm going to kill it.
How do you know you want it to be all cosine?
Because I only got one sine squared. I could, by the way, change everything to sine squared too. That would be fine too.
You just want everything the same.
I want it the same, so I can do algebra on it. I want an X or a Y. I want one letter. I don't want this mess. I want one thing.
So like variables.
Like variables, yeah. So now I'm going to grab this. Whoop, I'm going to junk it right in there. And I get 1 minus cosine squared theta. Cosine squared theta minus cosine squared theta. Well, I'm showing you new stuff. This is the new day. This is the, you got to do a little bit of this. You are absolutely going to have to practice this before you'll start seeing things. It's just going to take a while. It is. Okay, I got a distributive property, don't I? So I've got cosine squared theta minus cosine to the 4th theta minus cosine squared theta.
What is that?
I just did distributive property. Doing algebra?
Which ones?
Well, I did this outside the parentheses here, right? So I did cosine squared times 1, cosine squared times cosine to the squared, cosine to the 4th. And looky here.
In the second part, don't you have to distribute, when you have another cosine 4 squared? Or
Why?
cosine for.
I'm distributing this in like this, right?
Oh,
Got
you
the
don't
parentheses?
answer the second one.
Yeah, second one just hanging off with a minus on it. Good? All right. Pain and suffering. Delivered here for free. And I want to simplify it. So, first thing, do good algebra. There's no good algebra to do there, right? Second thing, change everything to sine and cosines. That's 1 over cosine x over sine x over cosine x, right? How do I do a fraction and fraction? Flip and multiply. Times, flip, cosine x over sine x. Cross them out. 1 over sine x. That's done. Or you could write it as cosecant x. That's also okay. In fact, most people say that was better. Either one is okay.
It's 1 over.
It would be 1 over, wouldn't it?
Well, isn't you cross multiply, right?
We're not cross canceling is what they called it way back in 4th grade or 5th grade or whatever it was. It's the idea that I'm dividing top and bottom by cosine x,
Okay.
right? To get rid of a like term.
Yeah, because I just.
That's
Cross
factors
multiply.
cancel. I'm not cross multiplying, I'm multiplying. That's where you multiply fractions, right? Just multiply straight across.
Yeah.
1/3 times 3/9
Mm-hmm.
is 3/27.
Yeah.
Or I could have written that as 3 over 3 times 9, which means the 3's cancel out. Yeah? Okay. Good? 5 is another one that's a bone breaker. Do you want to try number 5? Plus. If that was a plus, this would be tangent, right? Because sine over cosine. You do it like one step, that'd be awesome. Well, it's sine over cosine, right? If these were the same, I could just make it one big tangent, couldn't I? But they are not the same.
But that's not what I did.
That's what you more or less did. But yes, what do you do?
I did, like, so I thought that if it's theta plus pi, that's basically, isn't that the negative there? It's just a different, wouldn't that just be then negative theta? So the sine of negative theta is negative sine
Well,
of theta, and cosine of negative theta is just cosine.
it's not bad. The problem is not sure that works.
Yeah, that's good.
But the idea is an interesting one because it repeats every 2 pi, doesn't it?
Yes.
So I can add 2 pi or take away 2 pi because that's what that identity said. It doesn't change the answer, right? I can add 2 pi to the inside and it doesn't change the answer.
What? Oh.
Remember that idea? If you add 2 pi, you get the same answer, right?
And
What would happen if I added 2 pi to the bottom?
Oh, wait, why would you do that though?
Because I wanted these to match. Because I look at this, I see sine over cosine. I said, if these 2 angles matched, I could just write tangent of something. And that would certainly be simpler, wouldn't it?
Okay.
So 1's minus.
But 1 is minus, so I couldn't do it. So what do I have to do to fix that?
Make a.
I'm allowed to add 2 pi. What happens if I add 2 pi to the bottom? Well, let's take a look. Simplify. Simplify, what do I get?
Oh.
Now do they match?
Yeah.
Not going to write as tangent?
No. Yeah.
What's sine over cosine? And they're the same angle, so I'm now allowed to do that. So I'm allowed to write this as tangent theta plus pi.
You just threw in a 2 pi there.
Yeah.
Yep.
That seems
Every 2
hardly
pi
legal.
repeats, right?
Yeah.
So cosine theta plus 2 pi is equal to cosine theta, right? Right?
Interesting.
That's one of those identities on sheet.
Which one?
That's the 360 one.
Okay.
Thinly disguised as 2 pi.
Yeah.
Yeah. Now, is this the final answer? By the way, I can simplify it even more. This is so sick and wrong.
No, you can't.
How often does how often does tangent repeat?
Every pi.
Every pi, so I can add or subtract a pi. What happens if I subtract a pi?
It's tan theta.
Just tan theta. There you go.
I feel sick.
I do too. Look at that. It's terrible. You were so close. You had a minus tangent theta. That's why I thought you had the right answer.
No.
So close.
So we're actually gonna have to like do whatever you said you guys.
Yep, we'll practice it. We'll practice it. We got time.
Is it gonna get easier?
Nope. Nope, not going to get easier. Although you're going to like 6, I think. All right, Eppolito sounds like she's struggling the most. Let's have Eppolito do this one. Ready, Eppolito? I want to change everything to sine and cosine, right? So how do I change sine into sine and cosine? It's already there, right? How about cosine? Already there. How about secant? One over cosine. How about cotangent?
Sine over cosine.
Sine over cosine is tangent, so cotangent would be
Cosine over tangent.
cosine over sine.
Or over sine.
So that would be sine times cosine over cosine times sine. What do? Good algebra.
Can you go through the algebra, please?
It's all multiplied, so I can get rid of any common factors. Algebra, right? So 1 times cosecant is cosecant theta plus outers, negative cotangent theta. No, that was first. Firsts, outers, inners. Cosine theta, cosecant theta. Why not? Multiply by each other. If you want to branch around, you can. Better if I wrote that clear. And then cosine, and then minus cosine theta, cotangent theta, right? Having fun?
No.
No.
Boom. Roasted. Just flowing.
That doesn't.
1 minus cos squared theta over sine.
Now, there is no simplification here for algebra, so what do we do next? Change everything to sines and cosines. This is 1 over sine theta minus cosine theta over sine theta plus cosine theta times 1 over sine theta
Isn't that
minus what?
you just do cosine over sine?
Yes,
Oh, okay.
totally okay. I'm just doing it slowly. Cosine theta over sine theta. Agreed?
Yeah, but it's-
Okay. So now I'm going to simplify the best I can. I've got 1 over sine theta minus cosine theta over sine theta plus cosine theta over sine theta. Hey, wait a second. Aren't those the same thing?
They cancel.
A minus and a plus, don't they go away? Minus cosine squared over sine theta. So I got 1 minus sine theta minus cosine squared over sine theta. Agreed? Now, I've got one more glitch we have to remember. We just talked about it a little while ago, but you might not remember it, and that's what?
Oh, the 1 minus cosine.
1 minus cosine squared is?
Sine squared.
Sine squared. Shoot. 1 minus cosine squared is sine squared theta.
Oh my.
So that big old mess is sine theta.
That's wild.
That's way too loud for me.
Oh, yeah,